Hey people, so I've been wanting to do a video on inventory management with the programmable block, and I figured to do that I first needed to do something with string manipulation, which I haven't been wanting to do because it's a huge freaking topic. But I think I am gonna do a sort of narrow scope here, so I'm gonna go over a few use cases of string manipulation and a quick explanation of how it works. And hopefully that will be enough. If you have any questions, please feel free to ask in the comments because I'm not going to be exhaustive on this one. So why do we want to manipulate strings? Well, strings are strings of characters. They are text, and they are super useful because almost all blocks in the game contains text in some form of another, in the form of detailed info or custom name or even the custom data. Plus, if you want to type, for example, more than one line of stuff on a screen, you want to manipulate your string to some extent. You could make a single string, but you can also build them up. So yeah, I think first off we're gonna do something about just checking the capacity on the batteries over here and listing undefined number of batteries. So yeah, let's get to that. Alright, so since I want to work with an undefined number of batteries, I'm gonna make a list for the batteries. And I'm just gonna call that batteries and make it a new list. The whole new list thing, as I've discussed before, is, well, you need it, otherwise it's an undefined object. So to stuff all our batteries in there, I'm gonna do grid terminal system, get blocks of type, my battery blocks. That'll get all our batteries and stuff it into the list called batteries. And there we go. Now we have all our batteries. So actually I want to put that in my main loop in this case, because if a new battery is added, we want to know. And if it's up here in the program block, then it will only be run once. So I need a string, and I'm just going to start off with an empty string, and let's call it output. In the start of every loop here, I want to set that to being nothing. So 2 quotation marks makes that an empty string. Now for every battery I have, so for int I equals 0. So we're making a counter called I, and that starts off as 0, while that I is less than the number of batteries, so batteries.count. We are going to increment that value I. So what we're going to do is we are going to take that output and we are going to add to it. So we're going to say plus equals. That means we append something to the end. We take whatever is in output and add something on top of that. So what I want is I want a /n. That is a new line. That means we go one line down on the terminal. And then to that I will add batteries, square bracket I. That means the ith battery in the list, and we want that one's custom name. So that is the name of the battery. Now we have our output only containing a new line, the name of the battery. And we're going to add the battery's stored power. I want that as a percentage because it's nice and small to work with. We could also do the megawatts or whatever, but yeah, let's do batteries. Dot stored. So the current stored power, we want to divide that with the batteries. It gets a bit long, but yeah, max stored power. So that we should get a decimal, and we want to multiply that by 100 to get the percentage. And then on the end here we are going to add a percentage sign. Oops, that's an ampersand. Percentage sign, and we may also want to add a new line. So total what we have here. Every time, for every battery we have on our grid, we are starting out with putting a new line into the output, then name of the battery, a new line, the current stored power in percentage, adding a percentage sign, and then a new line again to make a spacing for the next one. Now our font may be a bit big to store all of this, but yeah, it's going to keep adding to that output one, so it's all going to be contained in the string called output. What I'm going to do after we have run that for loop, I'm going to do me.getSurface, so I'm writing on the programmable block, write text, and we can just add output there because it's also already a string, so we don't have to type in a string. So now we should get our battery information once this code runs. And it's set to run at update 1, so it'll run every tick. And it should update all the batteries on every run, so if you add batteries, that should be added automatically. So let's just take that into our game. Alright, here we are. So popping in the code, checking it's okay, it is okay. And there we go. So battery 2, battery 3, all at 100%. If I am to delete this battery, we got battery 2 and battery 3 at 100%. And if I am to add another battery, that is a small battery, so add one more. And we don't really have space on the text on the screen for, oh, and it's charging. So yeah, that is basically just constructing a string with a for loop. We could do the static one where we have a certain list, but then you have to use defined number of characters. A predefined number of blocks, because you have to kind of hard code it in, where this is flexible. We could change the font size and list a bunch more. Yeah, whatever really. So moving on, I want to do something based on custom data. So that's where we have to check a string if it contains something and then do an action based on that. So let's get to that. So expanding on our previous code here, I'm gonna add a list of pistons as well. So list my piston base pistons equals new list. Yeah, there we go. So we're gonna do the same thing. We're gonna say grid terminal system get blocks of type my piston base, and we're gonna stuff that into list called pistons. Right. So what I want to do is I want to go through all my pistons. So we're gonna do the same as we did down here. So I'm just gonna copy paste that because I'm lazy. Pistons and delete that. So for every piston we have, we want to check if pistons so the piston we're on at the moment, custom data contains this string here. So I'm just gonna say, let's call it up. So if the custom data on the piston we're on right now contains up, it doesn't matter if you have a ton of other text in there. If it just contains the word up somewhere, we're gonna do something. So we're gonna say pistons extend. So, oh, we need a bracket there. So if the custom data of the string of the piston contains up, we're gonna extend it. If it doesn't, so we're gonna say else, then we are gonna retract. So all the pistons containing up in their custom data in some form or another is gonna extend. All other pistons are gonna retract. So let's try adding that to our code. Alright, so we are adding the code in here and it checks out alright and it doesn't crash. Great. So now we have 3 pistons over here. So if I add to the custom data up, it's gonna extend the piston. If I add to the custom data get up, it's gonna extend the piston because it contains up. If I say what's up, it is still gonna go up because it contains up. So yeah, and if I am to add another piston to my grid right now, since we are running the update on every loop, and add up to the custom data here, it is gonna go up. So yeah, the contains function is pretty powerful, especially with using custom data or names. For example, you could check the block's names all the way around, and if a block contains, for example, you can check for don't charge on the block name. If that is contained, then we don't charge that. We could do that in code or something like that. So that is pretty neat. Also, you can check for, even if something isn't spelled correctly, you can still get it by getting a snippet of text. Second to last one is just going to be some argument handling. It isn't strictly string manipulation, but it's still rather good to know. So let's just do that quickly. Alright, so we talked about the argument up here before. It is the line of text you can run when you run the programmable block, and it will be passed to the code. So to do a bunch of things with that, I'm going to make what is called the switch statement. It will check a variable and then it will compare different cases. So we're going to say switch argument. So it's going to do something based on that argument. Now we can add cases, and they're a bit counterintuitive compared to regular function because you don't need a bunch of squirrely braces all over the place. So let's say I want a case where the argument is up. So if it is up, we're going to do the following. Now I want to do the whole piston extending and retracting thing in there instead of this custom database thing. So I'm going to take that here and stuff it in here. Then I'm going to add break. You need to add break or continue after each case. If you say break, it checks if it hits up. If argument equals up, it's going to do this and then jump out of the switch statement. If you say continue down here instead, it's going to continue checking all the other cases through just to make sure that it only matches one case. And if it matches multiple, it's going to run multiple lines of code. So yeah, if the argument is up, we are going to extend all our pistons. So let's just replicate that because I don't want to type it all out again. So if it is down, we are going to retract instead. Now, one issue here might be that the person who wrote the argument wrote up with a capital U instead, and then it's not going to work because it has to match exactly. The argument has to contain exactly this with lower and upper cases, or it's not going to work. So how we can fix that is in argument up here, because it is a string, we can type a period and say to lower. That basically means we are checking argument, but we are putting everything in it to lowercase. So even if we wrote up in pure capital letters, this will still work. Without this little addition, it has to be typed exactly as it is here. Okay, so two cases a bit boring, so I'm just going to add what I'm going to add. I'm going to add cases for turning off the battery. So case battery off, right? Case battery off. Let's just be lazy and copy some code down here. So instead of putting to output, we're going to do batteries I enabled equals, I can't type, I've had way too much copy today. Okay, enabled is false, so we're turning the battery off. And then we're going to add break, otherwise it ain't going to work. And then we're going to put a case in called battery on. Same deal, just going to copy all this. And battery enables equals true. So now we have 4 cases here. So now we can wire up some buttons or something to access those to pass the argument to the programmable block. So let's just try it out in game. Alright, back in game. So let's stuff in the code. It's running. So if I type down here in the argument, run that, it's not going to work because I am a bit of a fool and I've got to remove a bit of the code. We still have the for whatever extend here, so it's going to extend forever. So I'm just going to remove that. There we go. Alright, so if we run down now, they are all gonna retract. And since it's an argument, we can pass that with a button panel or a cockpit or whatever. So let's just add a button panel here. See back here what we can actually see. So the first button here, I want to say run with up. Next one's gonna be run with down. Next one is gonna be battery on and battery off. Alright, so if I press the first button, let's just do like that, they're gonna extend. Press the second button, they're gonna retract. Press the fourth button, batteries off. Third button, batteries on. So we just add the functionality to buttons, and you can use that in an action bar in a cockpit or whatever as well. So strings, they are pretty neat. The last thing I'm gonna add is gonna be a bit, I won't say theoretical, but it's behind the scenes, so you won't really see it happen. And I use it very rarely, but for some people this may be super useful. We're gonna use storage variable to save data between recompiles and between saving and loading, because your code is reset every time you load the game. And some people may want to have some data persist. So let's take a look at that. Alright, so as I said, the storage container, let's call it that, is very useful for storing stuff between saves and loads and between recompiles and stuff you generally just don't want to save. For example, I use this a lot with my space elevator constructor, my mining rig and stuff like that, to keep track of which state it is in, so it doesn't, for example, try to tilt the drilling tower down when it's in the ground if I save and load while I'm drilling, or my constructor can't remember what state it's in, or it's going to fall off the tower, stuff like that. So how we store things through states is this function down here, save. It's going to get run every time the game saves. And there is a variable called storage that is saved. So what we want to do is when we save, we want to stuff our data into that variable. So storage, as you can see, it works even though we haven't defined it, because it's defined by the game itself. So I want to save these 4 variables in storage. So what I'm going to do is I'm going to say that it's equal to password, and then I'm going to add this. That is just so we can split the data up later. It could be any symbol, but this one works because you usually won't have that in any of your data. So I'm going to add code state and then say to string. That's not strictly necessary, but it makes things easier. So I'm adding to string, so I turn this integer into a string. I'm just going to continue, so we add another, because we want one of these indicators between every piece of data, so we know what belongs to what piece of data. So I'm just going to continue here. So plus base location to string, plus another one of these squiggly squiggles, and plus all processed to string. Alright, so every time we save, our password, our code state, our base location, and our all processed will be saved in the storage. That's great. How do we get it out again? So every time we load our game, every time we recompile, a program is going to be run first. So what we want to do here is we want to check, is there anything in storage? So what we can do is say storage.length. So that is the length of the string that is storage. If that is greater than 0, storage must contain something. And since we only stuff all of this into storage, it must contain all our data. So if there's something in storage, we want to get it out. Now, how are we going to get it out? We are going to make an array of strings. That is basically, let's call it a bookshelf, and on every single shelf we can have a string, a specific string, and we can define how many shelves we want to have. So I'm going to call this storage out, and that is a new string. Let's just type that properly. And we're going to add the close brace again. Here we have to define how many shelves do we want in the bookcase called store out. So we have 4 different data values we want to save, so let's just have 4 strings in there. Right, so now we have that. Now we need to make this string into 4 strings that we can then type in, turn into data. So what we're going to do is we're going to say store out is equal to storage, and then we're going to split storage. So we're going to say split, and inside that we need to add a character. Here we have to do the single quotation marks because it's a single character, it is not a string. So we're going to add the character that we use to divide our data down here. Now store out has 4 different strings. It's like the list, so we can access it with the squirrely bracket and a number. But that's going to contain a string for every data value we have, and it's split at this icon here, and that's not going to be included. So it's just going to stuff this into store out 0, this into store out 1, and so on. So now we can start getting our data out. We know the first one is our password, so we can say password is equal to store out 0. So the first one in store out. And code state is a bit different because it is an integer, it is not a string, and store out contains strings. So what we're going to do is we're going to say it's equal to int pass. Pass is where it tries to take a string and turn that into an integer in this case. That can fail if the string is weird and doesn't actually contain an integer, but in this case we know it does because we stuffed an integer into it to begin with. So int pass store out 1. So that's going to pass the text, the string in store out, turn it into an integer, and now our code state is equal to that integer. And it's again a bit different when we get to the vector 3D. That's why I've taken those, because they all have to be done a bit different apart from a float, I guess. So in the case of a vector 3D, we can try parse. They're a bit more complex, so we only have try parse. We can't just parse. Try parse is basically the same as parse, just behaves a bit different. So how we're going to do that? We are going to do again store out, and in this case we're getting to the value number 2. Then we're going to do a comma, and then we're going to type out. That is because this function, it works a bit differently. Instead of passing the value where you can say it's equal to, you have to tell the function where you want the value put. So we are going to say base location here, and it is going to stuff that into base location. And lastly, and with our all processed, we are just going to do the equal like we did with the int. So float pass store out 3. So that is the last one of our 4 values. Right. So what we've done here is every time we save the game, storage is filled with our password, our code state, our base location, and our all processed. All turned into strings apart from the first one because that's a string already. And every time we recompile our code or we load the game, it checks if there is something in the storage. If there is, we are gonna split the value of storage at the little mark, stuff it into store out, and then we're gonna try and pass out all different values. This works great if it is done exactly like that. If you try to pass a string called hello into a float, it's gonna fail, it's gonna crash your code. So in this specific case, this works, and you can just keep adding values down here and have in theory an infinite amount, but I wouldn't recommend just storing arbitrary values that is or can be hard-coded in your code. This is mostly for stuff that you get on the way. For example, the code we have has discovered the base location, the code state tells us which state our code is in. All processed is all the all processed we have all the all we have processed so far, something like that, and password is something we have maybe been sent from another antenna. Stuff we want to save but can't put into the code beforehand. So yeah, that is really all I have. There is a lot more to string manipulation. You can do a lot of cool stuff with it. I'm not going to go too much in depth. I just want to cover the stuff I may use in my inventory guide. So if you have any questions regarding manipulation of strings, how to check stuff, how to add or remove pieces of text, splitting, joining, etc., then feel free to ask in the comments below. I'll be happy to try and help. So yeah, thank you for watching, and see you.